again, this should be review stuff from Algebra 2. So go. Alright? This would mean your complex numbers are the old square roots of negatives. Okay? I being the most basic one, meaning I is the square root of -1, or just what we've represented as. This gives you the way to take care of all those zeros in the polynomials that don't fit under, the normal terms of taking square root of a positive number, which would give you the regular zeros that you're dealing with. The form a plus bi, if you remember, a and b are just the regular old numbers, the real numbers. Okay? You want to try and keep them whole numbers as best you can. You can have fractions there, that's fine. Just most of the time, though, if you're simplifying it, guys, you want them to try and be regular whole numbers. They don't have to be positive or negative or anything like that. Like, there doesn't have to be distinct order. Like, A doesn't have to be a positive number up front. B doesn't have to be a positive number adding. All right? It's just giving you the form that it needs to be in. And just remember, A and B are numbers. All right? So your basic ones, of course, would look like this. Like, for example, what they look like. And also, just remember, 6i, if I say convert that to something with the negatives, like square root of negatives, remember this is technically square root of -36. Right? Because square root of 36 is 6. Like if I actually broke this down, this is technically, right, square root of 36 times square root of -1. Square root of 36 is 6, square root of -1 is the I. Okay? So you just got to keep those in mind, the conversions. Like this one would be 6 plus square root of -4. You might, I don't think I gave you any of this, but it seems like it's a pretty redundant thing. Of giving you a number like 6 plus 2i and say, where are the real parts and where are the imaginary parts? But I'm not going to do that, because you should be able to look at it and go, oh, there's an I there, so that's the imaginary part. Everything else is the real part. But do have the understanding that, guys, this as a whole, that is a number. Like it's counted as a specific number. Even though there's two terms to it, right? There's a 6 and a 2i. It's still counted as just simply one number. Okay, that's why it falls under the whole complex number thing. Okay, it's just they're made up of two parts. Now, the stuff you guys are going to do with them, it's going to be your basic operations with these today and maybe some basic simplification stuff. The rules behind it with adding, subtracting, and multiplying are simply add, subtract, or multiply the real parts together. Well, add or subtract the real parts together and the imaginary parts. So rule-wise, the way it would look would be if I took this complex number, a plus bi, and added it to this other complex number. Because again, these are just simply numbers, both of them. I would take whatever the real parts are, in this case are A and C, and perform whatever operations there. Whatever the imaginary ones, perform whatever operations are there. It's just when you write them out, the B and D get grouped by themselves, and you just stick an I at the end of it. Alright, same thing goes with the subtraction, guys. You subtract them, you subtract the two numbers, the A and C, the real parts together, imaginary parts together. Making sure also, if you've got like a negative sign on that last one, like if the C plus DI part had a negative in it, you understand that the minus sign is distributing to both of them. So it means you're subtracting a negative number, which is in turn adding. You still have to think that way. Okay, that's why the parentheses are kind of important. And then when you multiply these, when you multiply, remember you multiply them just like you would any kind of binomial. All right, going back to your basic FOIL kind of stuff. The rule there just tells you how it's going to act if you were to break it apart. But in essence, guys, it really is just doing FOIL, where you do these two together. There's your AC. These two together. That's the those two together. And then those together. Everything is just distributed in evenly. be a, that should be a,
Should be a CD.
something.
There are two BDs, so one of them should be a CD.
Yeah.
First outer vanilla last, so we're trying to
The
see.
CB should be over here. AB there. This should be it. In terms of multiplying, because you got AC plus CBI, A plus BDI squared. Okay, like if you FOIL it out, so the I squared becomes -1. That's why it's minus CB and AD are right there, and the AC is right there. Okay. All right, now, okay, I got a couple examples here. There's one other thing, and that's with the complex conjugate stuff at the end. So your basic problems would be ones like that, okay? Remember, if add and subtract, be the easy stuff. You simply add the real parts together, add the imaginary. If I took these first two complex numbers and added them up, what would it be? 5 what? 5 is right? 3 plus 2 is 5, and then the other one.
Plus name. No, minus
5 minus 1
Minus
I.
Okay. And then the other one would be how much?
3. No.
Wait, no, not 3.
Negative 15.
Negative 15.
Plus 7I.
Minus the plus.
Plus.
Plus. All right. Because again, just remember, guys, like the minus is kind of distributing to both of them. So that's really -9 plus I. Okay? That's why it becomes 7. So 6 and 1 together give you 7. All right? So that's the biggest thing. I don't think I have a multiplying one up there because that'll come in the form of the complex conjugate thing when we get there. Just don't overthink them, guys. If you're adding them, that. Don't overthink it. Don't look back at formulas or anything like that. You're going to confuse yourself. You're just subtracting, just subtract. Don't overthink it. Okay? All right, so the other thing, this would be the dividing part. It's the only operation that wasn't up there yet. Okay, so the dividing thing would be like if I took a number like a 2 and divided it by like 4 plus 2i. Okay? When you divide them, guys, you don't really leave imaginary numbers in the denominator. All right? You try and always keep them in numerators. This is a matter of just simplifying. When you simplify these, or when you divide like it is up there, two complex numbers, basically what you do is you take whatever the bottom is, okay, and you do the complex conjugate of that denominator and multiply top and bottom by it. Okay, if you remember, the complex conjugate is just the opposite sign in the middle. So if it was C plus DI, the conjugate that would be C minus DI. All right, and the reason for that is when you multiply those together, it kind of just cancels out the imaginary. All right, just in the same fashion of if I did, it's the same idea as if I did x plus 2 times x minus 2. This just becomes x squared minus 4, right? The middle terms cancel out because it would be a positive 2x plus a negative 2x, which is 0. That's the whole idea here, is you want to get the imaginary numbers out of the denominator. All right, you still have them in the top, that's fine, it's not an issue. Okay? So, like for example with these, okay? If I said, all right, I want you to take this and express it in the form a plus bi, which means I want everything on one level. I don't want any fractions, like no big fractions. You could still have fractions in there for a and b. You just don't want it all on one level like this, or two levels like this. Okay, so, and you would do, you would multiply top and bottom by the conjugate, the complex conjugate at bottom, which is just simply changing it to plus 2i. All right, because you want those two to be opposite signs, because when they're opposite signs, if you multiply them and cancels out all the i's there. All right? And remember, you have to do it on top and bottom because it's technically like you're multiplying by 1. If you multiply something by 1, it doesn't change the value of it. Okay? So, on top, you'll have 2, right, minus 3i. I'm going to write every little thing out on the first one. Plus 4i. Correct? Right? Minus 6i squared. Is that okay? Okay? And on the bottom, you'll have parentheses 1 minus 2i plus 2i minus 4i squared. All right? And like I said, the whole point of doing that is on the bottom, those subtract each other out. I squareds, guys, make sure you go in and replace them all
With -1.
negative ones to plus I 1. Right? And plus I would be the -3 plus 4. All right? And then once you do that, you should get something that, and again, I'm writing out every little step on the first one here. You get something that looks like 8.
What is that thing by the minus 6 at the top?
That negative 1. 8 plus y, I 5. Now here's the thing with this. This wouldn't be the technically correct answer for the form I wanted in. You still. That's technically how it would look. Okay. All right. I'll just do one more. This will be the last thing. All right. So if I was to express it in that form, right? Complex conjugate on the bottom would be that. So it'd be top and bottom like that. Multiplying those out, right? The bottom part should become 4 minus 9i. Right? Because the I terms cancel out, so you don't even care about them. You just care about the first 2 terms multiplied together in the second one.
Isn't that 9i squared?
Squared, sorry. And then on the top, right, you got 52, right? Plus 78i plus 78. 78, right?
Yep.
Plus
Yep.
117. Okay. Replace the I squared with your -1. I'm not going to show the entire step, but understanding that this would become 4 plus 9, 13 on the bottom. This would become -117. So -117 plus 52 is how much? 5. And then the 2 i's together would give you 6. All right, and then again, like I said, I would want you to break that apart. 1, 2, 6, 7. Yeah, that's right there. You're breaking 5. 5. This 5. Yeah, sorry, I don't remember. Oh, -5, and that was 12. There you go.